We're going to start off with Konstantin Malkov from Five9. Before I came to Microsoft, I was a New Jerseyan, so Konstantin's a fellow Jerseyan. Welcome.
Hello, everybody. I'm Konstantin Malkov, CTO of Five9 Software, and as Bob mentioned, we developed an application called Five9 Cloud Security for Hyper-V. Basically, this application solves a couple problems. First of all, it is a security application, and you know that these days the amount of different malware, spyware, viruses, and all kinds of hack attacks grows exponentially, if not faster. So enterprises, public sector, and SMB need tools to protect against these attacks. Especially it is important in the cloud, where you have virtual machines and virtual private servers that need to be separated, and traffic needs to be controlled in a multi-tenant environment. So in case one virtual machine is infected for some reason, you know, the others are protected. Plus, of course, security needs to be managed on a per VM basis. So we developed an application that has three components, and as Bob mentioned, we actually utilized Hyper-V extensible switch. You could see here in Hyper-V Manager that there is a Five9 virtual firewall extension. It's a filtering extension. Elegancy of Hyper-V switch allowed us to develop agentless solution for both virtual firewall, intrusion detection system, and antivirus. So it was the first solution that was truly agentless. Earlier versions of Five9 Cloud Security for Hyper-V required installation of the agent inside the guest operating system, inside the virtual machine, but not starting version 3 when Windows Server 2012 and Microsoft Hyper-V Server 2012 appeared. I'm going to show today briefly features that allow you to set the rules for virtual machines or for groups of virtual machines, which is very important. And by the way, we just released version 4.1, which has a full multi-tenancy support for both domain, work groups, and mixed environments. So it has been released, and many hosting providers, public sector, and enterprises are deploying this application with Windows Server or Hyper-V Server. So, the application exists in two flavors. There's a standalone application, which I showed. It's a management console where you could you see the host system, you see tenants. You could create global rules or local rules for virtual machines. You could create different tenants and users. So. And of course, it allows you to view the logs, virtual firewall logs or intrusion detection logs for virtual machines. So what I'm going to do here is, this is actually quite a simple example here. You could see that there's a virtual machine. This is CentOS virtual machine. It's loaded here in a Hyper-V Manager console. And there is a client machine, which is called Windows Client right here. So what I'm going to do here, I'm going to load, I'm going to try to access web page on that CentOS web server here. And you see that there's a allowing rule. This CentOS virtual machine belongs to virtual machine group called web servers, and you see that web servers virtual group has HTTP allowing rule. You could create other rules, like for example, if I would want to create a rule that would allow also ICMP traffic to that virtual machine, or to or in. And I would say that I would allow ICMP traffic either bidirectional, or one you could select inbound to outbound. You could specify local ports. You could remote ports. You could specify that you allow this traffic between specific virtual machines, a part of your virtual environment. And we also have templates that allow you to implement and create rules for common scenarios, such as, for example, FTP server, HTTP server, and so on. And this management console, this is, as I mentioned, this is one type of GUI. Another type of GUIs, we have the virtual machine manager plugin. So all of the functionality that you have available, including the virtual machine security groups, in standalone console, you could also implement and access in a virtual machine manager plugin. So anyway, what I'm going to show here shortly is, briefly, is as I mentioned, there is this web servers virtual machine group, and as you see, there is a TCP/IP traffic allowed on port 80. So this web page is displayable, and you could see that I can go here and I can refresh the page, and it is accessible. Now, if I want to take this machine and remove it from this security group, then when I attempt to access this page, let me go here and do refresh. Something is timing out, I guess. Let's see here. Did I do the right thing? Yes, something is wrong with the adapter, I guess. Let me play the video that shows how this actually works.
Cloud Security for Hyper-V is the agentless security and compliance solution built specifically for Microsoft Hyper-V. Five9 Cloud Security consists of three main components: management service, which acts as a management server; management console for Five9 Cloud Security centralized management; and host management service, which is installed on each Hyper-V host intended for protection. This makes Five9 Cloud Security easy to install and maintain by administrators of any level. Let's have a brief look at the way it works on the Hyper-V level. So if you go to Virtual Switch Manager on the Hyper-V Management Console, you can see the Five9 Virtual Firewall extension integrated into the Virtual Switch. The current version is version 4, and this is the one which allows Five9 Cloud Security to completely control traffic inside the virtual network. So let's have a look at the management console, and as you can see, the virtual machines were not monitored with our firewall protection. So therefore, at this stage, you can access each other with no problems at all. So these are two virtual machines. One of them is Windows client, and the second one is CentOS virtual machine with Apache web server installed. So while virtual machines are not being monitored, you can see that Windows client can easily access the CentOS VM through the web interface, as it is a web server, and it can also ping the virtual machine. So ping requests go through and they work. So let's have a brief look at the rules enabled. So right now for all VMs there is a setup which has ISMP traffic allowed and RP traffic allowed on the network. So we enable monitoring on Windows client and CentOS VMs, and you can immediately see what happens throughout this way. I just remind you that ISMP traffic is allowed, RP traffic is allowed, but there is no allow rule for the virtual machine to receive the HTTP traffic. This means you can completely isolate virtual machines from each other, and they'll be entitled only to the traffic you allow them to use and to communicate with each other. So right now, let's have a brief look at the web service group, which has HTTP rule allowed and ISMP traffic blocked. So we'll add the CentOS virtual machine to the web service security group, and it should immediately use the rules assigned in that web service security group. So right now you see that HTTP allow and ISMP block are effective for the CentOS virtual machine. So let's go back to our test system. So you see that Windows client can easily access the web server now, but ping requests immediately stopped working. So I remind you that we just allowed the HTTP traffic to the CentOS virtual machine by adding it to the web service security group, and we blocked the ISMP traffic. Security groups allow to conveniently set up firewall rules for multiple virtual machines playing the same role, and also allow to conveniently set up a group of virtual servers. So what we are looking at right now, we are looking at the Windows Client 2014 virtual machine, and that virtual machine doesn't have the HTTP rule allowed. So we are going to create a web clients security group, and this group will include the HTTP outbound allow rule, and we'll assign that rule to a group of virtual machines which play the client's role. So as you see, we are adding the Windows Client and Windows Client 2014 to Web Clients group, and the Windows Client already had HTTP allowed rule, but on the virtual machine level, and right now we are adding both of these virtual machines to Web Client Security Group, so therefore both of them received the HTTP outbound allow rule. As you see, we refresh the page on Windows Client 2014 virtual machine, and it can easily see the web server on the CentOS virtual machine. What we are going to do next, we are going to set up the specific requirement for web service security group to allow its communication only with the security group of web clients. So the web service security group right now is allowed to receive the HTTP traffic for web client security group members only. As you remember, Windows Client virtual machine has the HTTP rule allowed on the virtual machine level, but right now we just removed it from the security group, which was called Web Clients. Right now, Windows Client 2014, which is still a member of this Web Client security group, can still access the web server, but when we start to refresh the page on Windows Client virtual machine, which was just removed from Web Clients security group, you see the page becomes unaccessible, so page cannot be displayed. Let's add it back to security group to demonstrate that this is the actual reason. So we add it back to web clients, press OK, you go back to the virtual machine, and here where the magic happens. So the virtual machine can see the web server again. Everything is done in a few convenient steps, and this allows you to do the management scenarios very fast. Right now, let's have a look at the intrusion detection system capabilities. To do that, we'll run a...
Yeah, I also, actually that was the same host system and virtual machine that I was going to show it to you live, but something is wrong with the adapter, I guess. But I will mention briefly that we do have intrusion detection system. It's using the same call-out kernel mode driver and filtering extension. So basically, what it does, it analyzes the packets and matches it against the snort signatures. So you could see here that IDS system displays the log. There was an attack, application level attack to virtual machine that in this case is web server, and of course you could filter log. It's stored in the database, and you could then correspondingly set the blocking rule that would allow that would completely block traffic from the source. And the third component is agentless antivirus system. It's a unique technology that basically allows to perform agentless antivirus scans without installing agent inside the virtual machine. And it's a module that works in conjunction with the change block tracking driver. So when the scan happens, incremental full scan, it's extremely fast because only change sectors are checked. So anyway, thank you for your attention, and if you have any questions, I'm ready to answer now or after the session. Thank you.
Thank you.